Welcome, Geometry Humans. This is another video about angle relationships. This is part 2 in a 2-part series, so you've made it to the last video of the series. Well done. You have binge watched this entire series, and you're going to have all kinds of angle relationships in your brains after this. Let's go ahead and dive right in. We're talking about angle pair relationships. All right, things we're going to talk about today: alternate interior angles, alternate exterior angles, same side interior, and same side exterior angles. Those are the 4 types of angle relationships that we're going to be hoping to master today. All right, so before we start getting into definitions and what these things actually do and what they mean, let's take a look at what these words mean. All right, so we have two sort of sets of words. We have interior, and we have, let's use this color for exterior. So we have interior and exterior. All right, so we have that sort of gray color and that sort of orange color, or green color and sort of orange color. So if we're looking for interior angles, we're always looking at these parallel lines. Let me just put the little marking on there so you know it's parallel. All right, we're always looking at those parallel lines. So if we're looking interior, we're looking at the inside in between those parallel lines. Okay? If we're looking exterior, that's all the space that is outside of those parallel lines. It is outside those lines. Okay? Interior is in between the lines, exterior is outside the lines. All right, so cool. Interior in between the lines, exterior outside the lines. Again, we're looking at the parallel lines. Let me re-parallel these guys. And cool, they are now re-paralleled. All right, so then let's take a look at alternate versus same side. So when we're talking about alternate versus same side, when we're talking, when we're looking at those, when we looked at interior versus exterior, we looked at the parallel lines. Are they in between the parallel lines or outside the parallel lines? For alternate versus same side, we're going to do the alternate with this sort of greenish color. And we'll do same side, we'll do something, let's do like this sort of highlighter yellow. Okay? What we care about is the transversal. All right, so the transversal is the line that runs. Sorry, I had to get my mouse back. Is the line that crosses both of those parallel lines. So if we're looking at alternate sides, we're looking at angles that are, the first angle is on one side of the line, and the second angle is on the other side. Or if our first angle is on, come on, Control Z, undo, there you go. If our first angle is on one side of the line, then the other angle is on the other side of the line. Why are you being weird? Okay. So alternate sides, we're looking for angles that are not on the same side of the transversal. Whereas same side, sorry, my colors ran away. Whereas same side lines, or same side angles, are all going to be on just one side of that transversal. They'll be either on the left or on the right or on the top or the bottom, however it's oriented. Whatever that transversal is, we're looking for the same side of that transversal. Okay, so let's take a look at some of these definitions. We'll take these words, we'll put them together. Okay, so alternate interior angles. Alternate interior angles, we're looking at 2 places. We're looking inside, right? Interior angles. We're looking inside the lines. I don't know what's happening with this. All right, we're looking inside the lines. And we're looking on alternate sides of that transversal. All right, so the only angles that show up inside the lines here are angle 3, angle 4, angle 5, and angle 6. Angle 3, angle 4, angle 5, and angle 6. So these are the interior angles, and we want alternate interior angles. So let's say we start with angle number 3. I'll mark it with this purple here. We want another angle that is inside that's attached to the other parallel line. So 3 and 6 would be alternate interior angles. Angle 3 and angle 6. Okay, so that would be one pair of alternate interior angles. Let's say we looked for another pair. Well, let's take a look at this angle number 4 here. Angle 4 and angle 5. So angle 4 and angle 5. Okay. Now, alternate interior angles are super useful and super cool because those angles are always going to be congruent. They always have the same measurement. And if you kind of look at them, angle 3 here and angle 6, well, yeah, that piece of pie, that wedge, looks like it has the same amount of pointiness to it. It has that same angle measurement. Same thing with angle 4 and angle 5. Those are also always going to be congruent. Okay? So those are alternate interior angles. They are going to be on opposite sides of the line, opposite sides of the transversal, and they're going to be both inside the parallel lines. So let's take a look at alternate exterior angles. Hopefully you have an idea where this might be going. See if you can come up with a pair of alternate exterior angles. Okay, so if we take a look at all of the exterior angles, we're looking at angles that are outside of the parallel lines. We're looking at angle 1, angle 2, angle 7, and angle 8. Okay, so if we wanted to pair up our alternate exterior angles, if we look at angle 1, that's one exterior angle. There's one that matches it down below. What angle do you think that is? That angle is angle 8. Those are on opposite sides, those are on alternate sides of our transversal, and they're both outside, they're both exterior of those parallel lines. Which means that angles 2 and angle 7 are also alternate exterior angles. Okay, so we have angle 2 and angle 7. And then we also have, okay, become yellow, angle 1 and angle 8. All right, don't get super in love with these numbers because they really aren't super important. It's just the best way that I have to label these. All right, and if we take a look at the amount of pointiness or the wedge here, what do you think you can say about angle 1 and angle 8? What do you think you'd say about angle 1 and angle 8? Same thing, hopefully, you'd say about angle 2 and angle 7. They look like they are congruent. Okay? They are. They're always going to be congruent. Alternate exterior angles are always going to be congruent. Okay? So let's move on to some same side angles. So same side interior. Again, we're looking inside our parallel lines, but this time we want to stay on the same side of the transversal. Sorry, that word just kind of didn't make it into my brain. All right, so if we take a look at angle 3, angles 3, 4, 5, and 6 again are our interior angles, but if we look at angle 3, the one that's on the same side of the transversal is this guy, angle 5. All right, and then if we take a look at, let's say, angle 6, we want to find an angle that's also inside, but also on the same side of inside the parallel lines and on the same side of the transversal. So that would be angle 4. Now, if we look at these guys, so our pairs are going to be angle 4 and angle 6 and angle 3 and angle 5. Okay, so if we look at how much of a wedge these guys make, this angle here for angle 4, the angle here for angle 4 it looks way bigger than the angle for angle 6. And they are different, okay? They are different. in this particular setup. There's exactly one setup where they aren't, but don't worry about that. They're different, but they do have something in common. They are always going to be supplementary, which means if you add them up, they're going to add up to be 180 degrees. Okay? If you add those angles up, they're going to add up to be 180 degrees. Okay? So we're looking inside the parallel lines and on the same side of the transversal. Those two angles are always going to be supplementary. All right? Next. Same side exterior angles. So again, let's look outside the lines, outside the parallel lines. So all these angles are 1, 2, 7, and 8 again, but now we're looking on the same side of the transversal. So if we look at angle 1, the angle that's also outside the parallel lines but on the same side of the transversal is angle 7. So angle 1 and angle 7. If we look again outside the on the outside of the parallel lines, on the same side of the angles, on the same side of the transversal, we are looking at angle 2, also matching up with angle 8. Okay? Angles 2 and 8 are always going to be supplementary. Angles 2 and 8 are also always going to be supplementary. They look different. They add up to be 180. Okay? So for this next one, we're going to use those ideas and do some math. All right? So I'm going to scoot myself over here. Yeah, good fit. Whoops, I slid down a little bit. There we go. All right. I'm in the right spot for this. So we have two parallel lines. This time they're going sort of in an up and downward motion. They're sort of going up and down like this. And our transversal's cutting across like this. It's fine. They're still the same rules, all right? So first we're trying to find out what is the value of x, and then what is each angle's measurement. Before we can answer this, what is the value of x, before we can even set up an equation, we have to determine what kind of angles we're looking at here, all right? First, you want to ask yourself, are these two angles inside or outside of the parallel lines? Then you want to ask yourself, are they on the same side or are they on alternate sides of the transversal? These two angles are they're on alternate sides of the transversal. They're on alternate sides of the transversal, and they're both on the interior or in the inside of the parallel lines. So we use this shorthand. We could use some sort of you know what? I'm not going to abbreviate yet. So these are alternate interior angles. Okay? These guys are alternate interior angles. Not quite sure why this little box is here, but whatever, roll with it. All right, so what do we know about alternate interior angles? Alternate interior angles are always going to be congruent. They're always going to be the same measurement. So when we set our equation up, how can we set our equation up? If we take a look at these alternate interior angles, since they are congruent, they're the same measurement, we can set them equal to each other. So if I take negative x, all right, this is going to fight me for a second, hang on. All right, fine. Negative x minus 28 equals the other angle, which is 3x. Okay? So those two are equal. Now we want to solve this and get x by itself. So the first thing I'm going to do, I'm going to add 1x to both sides, plus x. All right, so apparently this is just going to be a jerk and not be nice. So plus x. Okay? So from here, we say, all right, these x's are going to cancel out, and this 3x plus x, we're going to have negative 28 equals 4x. Okay. Negative 28 equals 4x. I'm not quite sure why my pen is being such a jerk right now. So now, to unmultiply by 4, we're going to divide by 4. We're going to divide by 4. I'm sorry, I meant to put that this was plus 28. That's my bad. I'm making a mistakey. Here we go. Positive 28. Sorry. So 28 divided by 4 is going to be 7. So 7 equals x. All right, so there's our value of x. That was our answer for question number 1. Okay. What is each angle's measurement? So now we want to actually figure out what number of degrees we have here. So if we take 3x, or we take 3 and then something that looks like an x-ish, we want to plug our answer for x in. We get 3 times 7. That's going to be 21 degrees. So this angle right here is 21 degrees. And then if we take negative x plus 28, we plug in our 7 for x, so we have negative 7 plus 28. We get that equals 21 again. So this angle up here is also going to be 21 degrees. Okay? So that's your introduction to parallel lines and how those work. So you'll have an activity, a worksheet type thing to work with these. So make sure you have your notes, have those out ready to go, and you'll be using those on this worksheet. So with that, thank you so much. Have a wonderful, wonderful day. I will talk to you later. Bye, guys.